Assalamualaikum and good day. I am Zikri Arif and I will present my design pre-thesis 3 under the recursive design work based this semester titled polyLAB, Punggol Creative Makerspace. Before I start, Louis Kahn once said that a room is not a room without natural light, and the sun does not realize how wonderful it is until after a room is made. So, what's actually the big deal and relationship about natural daylight and architecture for this design pre-thesis? Let's start with the daylight issues that is generally impacting a large number of us, in which daylight could alter the psychological and physiological of a person, and it can lead to disrupting their productivity in their daily life, and the glaring daylight could hamper the occupants inside a space. And that is where I established a program brief for this design pre-thesis, where the main idea is to imagine the best possible outcome for the community through daylight play. The research aim established here is to design a high energy efficient building through the daylight strategies for the most optimum facade design and form that will correspond to the daylight behavior in Punggol, Singapore. As for the three main research objectives, it is to evaluate the advantages of using daylight strategies in an institutional building in Singapore, where the second one is to determine the design variance of external facade of a building that will correspond accordingly to the daylight behavior. And lastly, to identify the effectiveness of external facade by using daylight simulation software of VLux Daylight Visualizer. In order to achieve those research objectives, I have identified 5 daylight strategies that are going to be implemented. First, the orientation of the building, in which to avoid the east and west direct daylight onto the building. Number 2, by using a responsive shading system, customizing the external facade system to protect the building that responds to the daylight levels in Punggol. Next, by finding the reasonable window size that justifies the need of view, visual relief, or natural ventilation for the occupants. Also, to use daylight simulation strategy in analyzing and testing the most optimal shading system using VLux Daylight Visualizer. And lastly, by implementing passive natural ventilation to eliminate overheating and to avoid air conditioning usage. Anyway, there are many untold stories of Punggol where the current main social issues are the weak sense of community among the residents, as Punggol is relatively a new estate and it is lacking public amenities for the residents. Thus, the architectural aim of this design pre-thesis is to make Punggol a more vibrant town with a hub for the residents to work and play, and the architectural objective of generating a better socio-economic cycle through the involvement of Punggol residents. With that, a building typology of educational institution is chosen for this project and narrowed down to a creative makerspace building as a hub for the community to maximize the economic use of the site with the high density of Punggol residents. The proposed client is National Library Board of Singapore, in which their vision is to make Singaporeans readers for life, having learning communities, and to be a knowledgeable nation. Also, a work and play program approach is proposed, where work is to focus on the economic cycle and play is focusing more on the social cycle. Before we start the research, basic understanding of daylight quality has to be acknowledged, as 300 to 500 lux level is regarded as the optimum and recommended for educational institution buildings by the National Institute of Building Science USA. And to dive deep into the context of our site in Punggol, the month of February to May will have the largest number of sunshine hours. Hence, this research daylight strategy of using daylight simulation is to simulate the building on month of April. So let's go to the interesting concept exploration used for this research proposal. Stellation is a process of extending a polygon in 2 dimensions, a polyhedron in 3 dimensions, or a polytope in n dimensions to form a new figure in the context of geometry. The recursive principle of stellation can be seen here, where a regular square derived from an architectural grid can be transformed inside out to another shape, in this case, from a regular cube to a rhombic dodecahedron and into its further stellation polyhedra. Then, by deriving the planar surfaces of the first stellation of rhombic dodecahedron, I tried to make recursive transformations by taking certain planes and vertices to create interesting shapes and forms. As one of the objectives for this research is to determine the design variance of external facade, I tried to tessellate the derived shapes into a wall partition to experiment with the look and practicality. The form finding and the basic modulation of my first facade iteration is created by the tessellation of the polyhedra and the shapes that an exploration of this facade module named Cube V1 is created with variations of a shutter-like opening with a variation of 15, 35 and 70 degree angle. The detail of this facade iteration of Cube V1 can be seen here, as the tessellation of the Cube V1 is creating interesting patterns where it is transformed from 0 degree angle to the extreme 70 degree angle. In order for me to find the best design variants for my research objective, I tried to create another modulation named Cube V2, as this module is practically the same, but with less surface area exposed. The shutter-like opening can be transformed from 0 degree angle to 60 degree angle. We can see that the tessellation of this Cube V2 angle does create interesting patterns for external facade design variant. With these design explorations and the objective of identifying the effectiveness of this external facade, I have simulated these two iterations using VLUX Daylight Visualizer to test the solar radiation. We can see from these results that it is not up to the optimized level of 300 to 500 lux. Hence, further design exploration should be tested to get the best out of this exploration. So, I tried to study on the pattern from the facade modules with rhombus and half-hex shapes, but in order for me to retain the conceptual shape of triangle, as the network of triangulation is stronger and firmer, I tried to extract the 2D vertices from a plan view of my facade modulation and break it down into two iterations. We can see from this modular breakdown study that 60 degree angle and 45 degree angle could form a simpler and less complex modulation, as the practicality in fabrication and future maintenance are kept at the back of my head. So in finding the reasonable size iteration, I tried to limit the scale of the design variant within 1000 mm, as it is easy to fabricate and the ratio of the opening and shading is kept within balance. This initial tessellation study has proven that simpler shapes and simpler modulation could be achieved, as this is less complex than the Cube V1 and Cube V2. By naming this modulation Tetra V1 and Tetra V2, I have identified that the Tetra V2 module is much more practical, as 45 degree angle is easier to manipulate and the design parameter dimensions are further kept within even numbers. We can see that this final Tetra V2 iteration will have two parts, in which the height of each part is kept 1000 mm high and 2000 mm width. So the bottom part of Tetra V2 is where the heart of this modulation is. It will house a photosensitive panel that will detect the daylight level and will give signals and data to the top part. Also, it is angled 45 degree up to receive daylight from high angle, so that the daylight data could be detected no matter the weather condition. Also, it will have openable window for natural ventilation as a strategy to avoid overheating and the usage of air conditioning in a space. And the top part of Tetra V2 will have the kinetic responsive fins that will respond to the daylight level based on the data that the photosensitive panel receive. Also, low E coating glass panel is used for the window of the top part. The design anatomy of Tetra V2 is creating interesting surface texture when viewed from this sectional diagram. Now we can see the transformation of the kinetic shading, where it will have 4 modes depending to the daylight level of the surrounding, from 100% shaded down to 25% shaded. We can also see the details of this facade modulation, as Tetra V2 is made as a system that integrates and acting like a physical wall instead of being a double skin facade. So by making the size of the modules kept within reasonable size, the external view from inside space could be enjoyed easily without worrying the daylight glare. Next, to achieve the research objective of finding the effectiveness of this facade design variant and the advantage of daylight strategy, I have simulated the facade in 3 spaces: a classroom, an administration office, and a co-working space. We can see that from these simulations, reasonable and optimum daylight levels are achieved, as the green colors represent the 300 to 500 lux range. These daylight simulations are tested on the month of April, as it is the hottest month in Singapore. So let's go to the space planning of this proposed development. With the idea of avoiding west and east direct harsh daylight, I have planned the main spaces to be oriented to the north and south, where the spaces that is facing west and east are the ones that are going to have the Tetra V2 facade. The ground level will have outdoor and indoor interaction court or the presentation space, display gallery, event space, and the Makerspace zone will house metal lab and wood lab. And the basement floor plan will have the loading dock, security office, dock manager office, recycling center, and refuse chamber. Level 1 is where the rest of the Makerspace labs are housed, the textile lab, work lab, and laser lab. Also, it will have the viewing deck to view the event stage at the ground floor. Level 2 will have digital lab and classrooms. Level 3 is where the classrooms are, in which the classroom 2B is a space that have been simulated to determine the effectiveness of the Tetra V2 facade, where classroom 2B is situated at the far west end of the floor plate. Level 4 is where the daylight simulated administration office is, where I tested a working space for the workers to take and maximize the Tetra V2 facade advantages. And level 5 is where the co-working space situated, where it has been tested in the simulation that the facade also works here, as Tetra V2 facade is giving the optimum lux levels within 300 to 500 lux. Also, we can see here in the section where I purposely planned the spaces elongated from the north to the south, in which the spaces at the west are having Tetra V2 facade to respond to the daylight. And Tetra V2 facade could be clearly seen here in these two elevations at the north and west, where most of the spaces are covered with it. And this is the section view of the whole building. And this is the aerial view of the whole development. So, with this Tetra V2 facade exploration, it can be concluded that the facade works at a level where optimum daylight radiation and lux levels could be achieved when these 5 daylight strategies are implemented through the design variants of these facade explorations. And with that, thank you.